Hmm. Yes. Now our next topic is real-time dynamic programming. Before going to real-time dynamic programming, first we will understand what is dynamic programming. So normally in the dynamic programming, we have to calculate the value function. Value function means suppose see, here now the agent is there. So for each and every now here the agent is in this state. By taking some up action, it will go here, it will go here, it will go. Based upon the action, the agent changes from one state to another state. So for everywhere we have to calculate the value function, like value, v of s value or q value. So if we calculate this value, we know how good the state is. We can quantify by taking this. Suppose if I calculated these values here, by taking some action, right, I come to know like how good this particular action is. So that is v of s. Normally in the dynamic programming, we are calculating these v of s value for each and every state. So how what will happen, the dynamic programming and the real-time dynamic programming means, suppose see, if we take one example, suppose I am in Poteri. I am planning to go to Katankalattur, KTR. So in dynamic programming, what happens in Chennai, whatever cities are there, whatever places are there like KTR, Urapakam, SP Coil, everything it visits and it checks how good it is to reach the goal state KTR. So from the KTR to Poteri.
Got
In dynamic programming means wherever the agent is, we are in every iteration we are updating this value function value in each and every state. But to reach the goal state, we no need to visit all these states. Suppose if I'm here, if I want to reach the goal state means I no need to visit each and every state. But in dynamic programming, what we are doing, for every state, whatever states are there, I am updating the value for each and every state. So it takes more and more time and it won't suitable for the large problems, big problems. Now we will see how in dynamic programming that equation iterates. Normally this is the basic equation of the dynamic programming. V of s, we know for each and every grid cell we have to calculate the V of s value function value, Q value. How we are going to calculate max A? What is this max A? First, we have some actions. From here, what are the actions we can take? Left, right, top, down. So, if I am in this state, I have to do this equation iteration 4 times. For finding this value function value for this particular state, I have to run all these actions like and comparing all these actions values, then whichever the action has the highest value, that value will be this current state V of s. So this is max A. That's why here they mentioned it as max A. Now sigma s dash p of s dash comma s comma A. We know s suppose I am in this state, yes, I am taking this kind of action. So what is the probability to go into the next state? So S comma I am in one state and I have taken one action. What is the probability to go to this next particular state? This we have to calculate it. And here see, here I have mentioned sigma. So I have to do sum up every time. Next, R of S comma A comma S dash. What is the immediate reward I get when I move from yes, when I am in this state S, I have taken action, I am going to this next state as S dash. What is the immediate reward I used to get? Plus gamma, we know discounting factor, and V of S dash. V of S dash means again this loop here V of S we have written. So inside we have to write this loop one more time. We are expecting what will be the future reward from the state S dash. Suppose now I am here. Now I am calculating the actions. By taking the actions, I am calculating the V of S value. V of S dash means suppose from here I move to this S dash. So what will be the future reward? So here one more time the loop iterates. So this is the V of S. So like this we have to calculate for all the 4 actions. Whichever actions is giving the highest value, this particular state we are updating this value. So that is dynamic programming. The main biggest drawback in this dynamic programming is we have to, in each and every iteration, we have to update the V of S value for each and every state. So it won't suitable for the bigger, largest problem domain space. When coming to real-time dynamic programming, here we are calculating to whatever the agent is exploring the states. For that only we are updating the value, V of S value. We are not updating the V of S value for all the states. So it is a smarter version when compared with the dynamic programming. So in real-time dynamic programming, this is the equation it updates. See, here it is the big equation. In dynamic programming, this one is not there. We are not considering all the states. We are just considering now from S2, when I am in state S, take in action, what is the immediate reward, and V of S dash. In the next state, what will be the future reward. So this value is only which is updating. That is real-time dynamic programming. So it learns very faster because it is only focusing on what it needs.